Assalamualaikum to Dr. Muhammad Azlisha and Dr. Faqruldin. My name is Alya Azwa Binti Azwan and my group members are Afif Hakim bin Hasanudin and Abdul Aziz Faqruldin bin Muhammad Roki. Our topic is stress monitoring in pandemic lockdown using IoT.
The COVID-19 pandemic and lockdown have taken the world by storm. The duration of the quarantine has made people develop feelings of anger and will become stressed. The danger of this stress is that it can affect not only our quality of life, but the people around us, such as our family and close friends, can also be affected by it. Not everyone can immediately realize that they are suffering from severe stress. This condition can be detected and treated immediately. It is hazardous to someone who has a high level of stress. However, to know whether people have stress, it is essential to monitor their stress level during the lockdown, especially someone who in a quarantine. Someone can detect the stress levels by using a heart rate. Therefore, this project aims to design a stress monitoring called a stress tracker by monitoring heart rate levels and then monitoring in real time using IoT implementation. Finally, it is believed that this device will help people monitor their stress levels during a pandemic lockdown.
Problem statement. First, people have limited access to mental health service due to the pandemic lockdown. Second, people do not have device that can determine accurately stress level of health. Third, people has limited social distance for monitoring the stress during COVID-19. Stress level. Stress is related to the heart rate speed, which the more emotional a person are, highest their heart rate are. Maximum heart rate of a person is depend on their age. Normal heart rate when relaxed 60 until 100 dBm. For normal heart rate when stressed 150 until 250 dBm. In the right side, we can see here pie chart that represent the comparison between relax and stress.
Our objective is first to develop heart rate monitoring by using IoT implementation and next to observe the stress level. Design and analysis. Circuit diagram. This is the entire circuit and its component. The components that involve are finger detection heartbeat sensor module detector, red LED, Node MCU as microcontroller, and battery 9V for supply. Block diagram. Starting from input sensor is finger detection heartbeat sensor module detector. After that, the data will be transferred to the Node MCU ESP8266 Wi-Fi networking. The microcontroller will be process the data and send it to the output sensors such as red LED. Then, the implement IoT, we develop one application that indicate the reading of stress by reading the heartbeat. Flow chart. First, start. Next, the sensor input will read heart rate. Then, LED turn off that represent the data have been processed and sent to the microcontroller. The red LED is an alert component to ensure people place their finger correctly. When the LED turn off, the sensor can read the heartbeat properly and the implementation of the IoT system follow. And lastly, the heart rate can be analyzed by using an application.
So this is a program that we use to for this project. So first thing is that to include the library that we use, which is the Node MCU library and the Wi-Fi client and the web server. And then as you can see here, we also include the index.h, and this is here. It's the file for to connect to the IoT to the internet. Okay, and then for this for SID, this is the Wi-Fi ID, and then this is the password for the Wi-Fi that we use. So this is the stress monitoring in pandemic lockdown using IoT programs. And then for these three line is to include the library we use. So for the NSU and the Wi-Fi client, and then for the web server. And then here we use the index.h. So the index.h file is to use to connect to the internet, to be displayed through online. And then for SID, we use the Wi-Fi name that we use, and also the password for the Wi-Fi that we use. And then the output will be displayed, we store at the IoT in internet. Then the port we use is analog 0. So the heart sensor will detect the heart rate, and then we send the data into the analog read 0. And then we use the pulse sensor variable. Also the LED we connect is to D1. And then so the threshold we use is 300. The reason we use the 300 is because we see from the raw graph we obtain the best threshold that we can choose is 600. Therefore we choose 600. And then we use digital write to display the BPM. And then we use the if else to either the heart rate presence or not. And then we use the serial print to display the BPM in the same monitor. So if when the project is turned on, the simulator will display the connecting in the serial monitor. And then if it's connected, you will say connected. And then you will say connected. And then you will give the IP address, the device, the IP address of this device. And then after that, after the run of the code, you need to make sure that we need to open up the website, which is the base64 encoder. We need to upload the image, which is this image. So we need to add this picture into the 64 encoder. We need to drag it. So we need to make sure that this code of line is the same as is in the index.h. So in the index.h, you can see the image src. This whole line was the same at the 64 base 64 encoder. Then afterward, we can run the program. So after finish compiling the program into the MCU, we need to make sure the Wi-Fi ID is the same one the device is connected to. So after the compiling is success, the simulator will show the connecting and then the IP address. And then copy the IP address and paste it into the browser. And then the heart rate sensor will collect the data and then display into the serial monitor and also to the internet. As you can see here, the data will be shown in the monitor and also at the same time at the internet. So the LED is to indicate the heart sensor and it's detecting a heart rate or not, and if LED is turned on, the heart sensor is not detecting a presence, and if LED is turned off, the heart rate is presence. So the heart rate we call it data and display into the internet. So this experiment is repeated a few times to obtain the best result, to get the stress heart level and also the normal heart rate. So for the normal heart rate is below 90 and the stress level is higher than 90. So after repeating this experiment a few times, so you're able to obtain the normal heart rate, which is below 90. So we obtain the 42 BPM, 72 BPM, and 90 BPM for the normal heart rate. And then for the heart rate, we obtain the 102 BPM, 158 BPM, and 162 BPM.
The first graph is represent the heart rate for 10 minutes. For the first of the 1 minute that show the first test by stress monitor, the result is 80 BPM. It will take for the 10 time until it become a 10 minutes. This graph actually represent result based on the heart rate that have been tested on one individual. The stress monitoring can be determined when the heart rate above 90 BPM. While below 90 BPM means the heart rate is normal heart rate condition. Even the person does not do some work or task, the heart rate still can be high. The result prove that the stress can be detected and monitoring when the person has thinking something problem that have been faced. For second graph, represent the heart rate at working hour. Next, the time taken to be observed for 10 hours. The working hour means the person have been works as employer in office hour. For the first of 1 hour that show the first test by stress monitor, the result is 80 BPM until it will take to 10 hours. This graph actually represent the result based on the heart rate that have been tested on one employer. When do any task or work, the heart rate also increase. It happen because the worker become tired or think hard to solve or identify the solution for the task given. Hence, the monitoring will help any employer or worker to monitor their stress and analyze it. The heart rate is normal or high. For final discussion, show in the graph. The graph show the heart rate change between the two different individuals. This graph has elaborated the data that have been recorded between two persons have aged 24 years old and another person aged 60 years old. Based on heart rate of person 24 years old, the graph always above than person 60 years old. The discussion based on this result, the person 24 years old have had more stress compared to the person 60 years old. The factor is happens because the person 24 years old always thinking about the salary, money to pay any bill such as bill hospital, bill water and the bill electric. Compared to the person 60 years old, the conclusion have been identified that person with young age easy to become stressed than old people. As a conclusion, stress is a serious mental illness if not early action taken. It may worsening the person's mental health. Heart rate can determine the person's stress level by using heart sensor. This project able to notify an early stress state to the user. Can reach help if not able to continue it. This project can be upgraded by counting the certain amount of time a person has been stressed, and by help of artificial intelligence, it can predict a person's potential health problem.